Welcome everyone to a next video of the series 100 problems around the world, and today we will visit the Israel Math Olympiad of 1997, their final phase, so their National Olympiad. The problem we have selected for today goes as follows. Find all real solutions of the system of equations. X squared plus y squared is equal to 6z, y squared plus z squared is equal to 6x, and z squared plus x squared is equal to 6y. Please, if you have any solution to this problem, please write it down in the comments. If not, as always, let's take a look at the solution together. So, we rewrite the request of the problem, so we are asked to find all real solutions for the system of equations which is given over here. Now, from these equations, we can easily see that all numbers x, y, and z are positive or at least numbers equal to 0, because each of them is the sum of two perfect squares, so neither of them can be a negative number. So they are at minimum 0, and they are always greater than 0 if not equal to it. So let's try to manipulate the given system of equations by subtracting the first equation from the second, and we will get that x squared plus y squared minus y squared plus z squared is equal to 6z minus 6x, or by doing some simple calculations we will find that x squared minus z squared is equal to 6z minus 6x, or that x squared plus 6x is equal to z squared plus 6z. So we can say x is equal to z by comparing these two sides, but attention, this is not because we have same coefficients from both sides, but we will now show that in this case, when x and z are both positive, real numbers, and they fulfill this equation, we can finally say that x is equal to z, because if we do the calculation of this system over here and bring everything on the left hand side, we'll have that x squared minus z squared minus 6z plus 6x. We can factorize x minus z times x plus z plus x, who multiplies x minus z, and we will get that x minus z times x plus z plus 6 is equal to 0. So this equation over here has two solutions: when x is equal to z and when x plus z is equal to minus 6. But this solution is not acceptable because we have already seen that x, y, and z are positive real numbers, so their sum cannot be a negative number. That's why we say that from this equation over here we get that x is equal to z, because if we were having that x, y, and z were just simply integers, there would be this other solution over here. So in a similar way that we just proved that x is equal to z, we can prove that y is equal to z, and in this case we will have that x is equal to y is equal to z. Now we can substitute in any of the given equations. We can substitute in the first equation, and we will get that x squared plus x squared is equal to 6x, or that 2x squared minus 6x is equal to 0, or let's factorize 2x and we will get that 2x times x minus 3 is equal to 0. We have two solutions to this equation over here, when x is equal to 0 and when x is equal to 3. In this case, we can say that the only solutions of the given system of equations are when x, y, z is equal to 0, 0, 0, or when x, y, z is equal to 3, 3, 3. Please let me know in the comment what do you think of this solution and if you have any alternative solutions.